Okay. So we have 2 points and draw the line to those 2 points. Same here. Now we've got 2 lines. Now substituting fairly arbitrary values for else might correspond. We'll say this is 14 and this is no. Okay. Let's say the coordinates this point are 5, 12. Coordinates this point are 9, -5. Thank you. Now, a little concerned because let me tell you plainly that open math isn't sufficient unless you're thinking through what you're doing, okay? And most people will work through open math, you know, under time pressure with a bunch of formulas in front of you, a bunch of explanations. As I've said, you need to work these problems, and you can do it that way, but then you really need to go back and see if you can work them without having anything in front of you. Okay? And I don't see evidence that most people are doing that. Okay? Now, if you have another way to learn it, okay, that's my advice. All right. Also, pay attention to what I'm telling you in class, because open math pretty much teaches you to do these things by using formulas rather than by seeing what's going on. And you really need to see what's going on to understand what graphs are telling you. So try to think about that. Now, you're going to see that, you know, what I do here is exactly what I did in class in several examples. And correct me if I'm wrong. Sometimes I get confused about what I've done in one class versus another. But, you know, if you look at the video, I think this is what I did. Unless I was looking at the wrong video. Okay. So, first thing you want to do when you have 2 points in a graph in a straight line is find a slope, and you don't do that by formula, you do that by a fundamental triangle, then you do it by a formula. If you don't understand the fundamental triangle, you don't understand rates, you don't understand what formula works, etc. Okay? And these are things you need to understand to do well. You might scrape by if you don't do this, okay? But you might not, because depending on how good you are at memorizing formulas and procedures. Good enough at memorizing formulas and procedures, you get by, but you're not going to totally understand, and you're not going to understand the applications. Okay? So I've emphasized these fundamental triangles. I only saw one paper with fundamental triangles, maybe 2. It should have been the first thing, and when I came around to look the first time, there should have been fundamental triangles. Okay? If you really want to understand them, if you're doing things in the way that I've explained. Now, if you use the formula and got the right slope, okay. It's not bad. It's not as good as it could be, and it's very easy to draw a fundamental triangle. If you're paying attention, you just do this. And you put some arrows on it, as I've demonstrated a number of times. And you label, you write out everything. You label run. This is 14 minus 0 is 14. Rise equals 0 minus 9 equals -9. So now you can say that the slope, I say, write this out, equals rise divided by run. Because if you're not writing this out, you're not reinforcing it, and you won't understand the connection with rate of change. You might memorize for a short time that this is what rate of change means. This is a pre-calculus course. In a pre-calculus course, you want to understand what you need in order not to have stumbling blocks when you take calculus. I've said this before, I think. So take a lesson, please, for your own sake. If you just scrape by in this course, you're not likely to pass calculus. Okay? You need to do a little better than that if you have calculus in the future. If you write these things out, you will be better prepared for calculus than you will be if all you do is memorize a few formulas and then forget right after this test. You won't forget this if you're writing this out in the homework. At least you're much less likely. And even if you do forget it, when you see it again in calculus, say, oh yeah, that's how we did it. It's the fundamental concept in calculus right there. It's that fundamental triangle. Okay? One concept that you need to understand what's going on in first semester calculus. So I'm emphasizing this for a very important reason, because I want you to succeed in this course well enough that you can succeed in calculus. And it's a stretch. Okay? It's a stretch. Given that you had your preparatory courses in a year of COVID, you need all the preparation you can get. Okay. Again, not trying to be mean, I'm just trying to tell you. Please do this. Okay, so rise over run. What's a rise? -9. What's a run? 14. And then we put the -9 over 14 here. And that takes 30 seconds. Unless the number is an asking, you got to use a calculator. Okay, that maybe takes 45 seconds. If you're a slow rider, maybe it takes a minute or two, but it doesn't take long. Okay, so there we have it. We now know what the slope of this thing is. Okay. So now we know that y for this equation is -9/14 x plus b. The slope is y equals mx. The equation is y equals mx plus b. Once you calculate the slope, if you have 2 points, that's really easy. And then what do? Then we take the coordinates of either point, plug them in for x and y, and solve for b. Now in this case, if we understand, and you should, and it's certainly what open math has told you, and that b is your y-intercept, so b is 9. So right there is our equation of the line, -9/14 x plus 9. Okay, very, very straightforward procedure that has a meaning if you see the meaning. Okay, well, here, you draw a fundamental triangle, you draw arrows, usually going from left to right. I'm not going to re-explain this, but now we can say, didn't leave myself room to label the run, did I? I should have probably done the triangle down. I could use either triangle. I'm going to use this one because it's easy to label. The run doesn't run into the labeling of my points. The run is changing x coordinates. Subtract where you start from where you end. 9 minus 5 equals 4. So let's put it over here since I'm using this triangle. Rise equals changing y coordinates where you end minus where you start. -5 minus 12 is -17. These numbers should make sense. If I go from here to here, I've got to go -17 in the y direction and +4 in the x direction. If you just use a formula, you're not going to see that. If you don't see that, you're not going to understand how this is related to rates when you need to. And again, you're going to have more trouble in calculus course. So please do this. Then the slope is rise divided by run equals -17 over 4. So y equals -17/4 x plus b. Now, this is the process that I used in class, wasn't it? Okay. Now, you've had 5 days since class, so you had time to digest that. Consider the idea that you should digest what we do in class. Click through the videos shortly after class so you refresh yourself. And then try to understand it as broadly as possible, because this isn't even pre-calculus. This is algebra 2. Okay? This is pre-calculus. We don't really start pre-calculus again until we get to the next chapter. Okay? Then it gets a little bit more demanding, which is why you want to understand this before you get to that. Because it makes that easier to understand, just for your immediate future. Okay? This gives you a better basis for understanding what the equation of a function tells you. Okay, well, there we have it. Okay, now, we've got a little more to do. We don't have B sitting there right in front of our very eyes. Okay? Here we did. So B. Not sure how good that is, but there's your process, okay? You got y equals negative 9/14 x plus b. B is your y-intercept. Y-intercept is one of your given points. You don't need to do anything more. Here, we're given the y-intercept. Now you can kind of estimate it. Let's see. If this is where y equals 12, then this, if this is 12, this may be 17. Okay? So I could estimate that should be negative 17 fourths x plus 17. Maybe. But we don't need to estimate. We know that when x equals 5, y equals 12. So, use a different color now. We get this. Now, this is a little exercise in equation solving that reinforces the idea that if you're going to solve this equation for B, you probably are best off multiplying both sides by 4, which clears out your fractions, and that's a really important habit. Saves you lots of pain. Okay? I'm not trying to give you pain, I'm trying to save you pain, right? So, we multiply both sides by 4. And you get 48 equals negative 68. And that's totally wrong. I didn't substitute for x. X is 5. A little jumble there. Make 17 fourths of 5 plus 4. It's just what we get here when we multiply both sides by 5. And we get negative 85 plus 4b. So 4b, 48 plus 85, well, that's going to be a picture can't be that far off. Maybe it is. It's 133. B equals 133 over 4, which is like 0.8. And a fourth, and I kind of don't believe that. Yeah, I guess I kind of do, because if this is 5, then 9 is about here rather than over here. So my graph, the scale of my graph is just that. 9 is less than twice as big as 5, but this point is way more than twice as far from the y-axis as this one is, right? So my graph just isn't very good. So that now I kind of believe my value on it, okay? So if I drew the graphs, of course I went by the original graphs. If I drew the graphs more accurately, I'd put the 9, -5 maybe about here, and it would have been much steeper. And then it would have made sense that it intercepts up here about 28. Okay. And actually, it's not 28. No, it's gotta be, yeah, it's 28. Okay. Again, check my arithmetic. This is the process that you see me do every time I do equation of a straight line, right? That's what I did last time. That's what I always do so far. Don't use formulas. But when you're doing the homework, do it this way and do it with the formulas. You get a deeper understanding that will benefit you throughout your studies in mathematics. Okay, please do these things. Now, if I want to then answer these questions, well, I'm going to need to make a couple of better graphs. First one is okay, but I've got it all cluttered up. So let's try to sketch graphs that match my coordinates. Okay, I've got 14, 0. And I've got 0, 9. This is 14 and 9 is about here. Okay, now we want to find out when y equals g. Or for what value of x does y equal 16? What x value corresponds to y equals, it's negative. Oh man, it's negative 16. I don't want to use negative 16. My graph. I've already messed up. The graph would be way out here to get negative 16. So we're going to say, okay, here, let's do 16. This is 9 is conceivable, but this is 16. So the graph should extend a little further. Now let's a little better. Okay. So come over here. You come down here. Right here is the point where y equals 16, according to my picture. What's the x coordinate here? Well, 14 is this big, so a negative 14 would be about here. Not a point on my graph, but it's a good. And so if this is negative 14, well, my darn, that looks like it's probably maybe negative 16. Okay. Well, let's see if that's correct. We want to do this by estimating. There's our estimate. Okay, just a coincidence. I came out with the same number, but negative. Okay, that's not generally going to happen, but it's an honest estimate. I could have maybe estimated negative 17. Okay. Okay. But I think it's a pretty good graph. So I think that I might be close. Now let's find out. Solve the equation. And of course, the equation of my mind is y equals negative 9/14 x plus 9. And y is supposed to be 16, so we get the equation 16 equals negative 9/14 x plus 9. Well, we multiply both sides by 14. We get 14 times 16 equals negative 9x plus 14 times 9. Now, I skipped a step. You need to write out the fractions. I totally understand why you're doing that. But 14 times 16 is 256 minus 32 is 224. Okay. And this is 126. So negative 9x, if I subtract 126 from both sides, I get 98, which means my estimate was really not a very good one. So we get negative 10 and 1/9, which doesn't compare well with negative 16, but so be it. I put my 16 a little bit too high, which moves things back. But if you're that far off in the graph, as long as you do the processing in the general ballpark, if I come out with a plus 10, that would have been bad, right? It's almost negative 11, which isn't all that close to negative 16. So that's what's usually better than that, but obviously not always. Okay. Now, I'm not going to do the same thing here, but I'd redraw this graph a little more accurately, reflect a decent scale, make an estimate, and then solve the equation. Very important to be able to estimate from the graph and then solve an equation to check to see if your estimate is close. If it is, then you probably solve the equation right. One way of quickly checking, because you can slap down a straight line graph very quickly. Okay. Well, that's that. Now let me pause a second. Okay, next thing we want to talk about is absolute values. I have to write down a few things. Like absolute value -7 is what? Absolute value of 16 minus 9. What? Let's see. I need to do that kind of quick and see how well you can answer these questions, and that'll tell me a little bit more about what I need to do next. Well, absolute value of the number is just its magnitude, how far it is from 0. Okay. We'll see what that means. If the absolute value -7 is 7, I think people know what absolute value is at that level. Okay. And the absolute value of 15 minus 9 is, well, that's the absolute value of 6, which is just 6. Okay, picture of absolute value. Here's 0. Here's -7, right? How far is this? 7 units. Notice it's just not an arrow. It's like a double arrow, so it just indicates how far, not whether positive or negative in a direction. Okay, so double arrow just indicates distance, which can't be negative. So, and of course, over here we have 6. Distance from 0. Distance is never negative. Okay? Because distance is like a double arrow, either positive or 0. Like the distance is -7 from -7 is 0, right? Okay? So distance is never negative. Another way of looking at this, here's 0. Here's 15, here's 6. Oh, sorry, here's 9. This distance is 6, right? So it's the distance between 9 and 15. Okay. So, absolute value of x equals 5. Well, x is 5, the absolute value of x is the absolute value of 5, that's 5. X is -5, the absolute value of x is the absolute value of -5, that's 5, right? That or is a big deal. Okay, well, on a picture over here, here's 0. You want points at distance of 5 from 0, right? Because that's what's going to make the absolute value of x equal 5. Well, that means you go 5 in this direction. You have this point, which is 5 units from 0, or this point, which is 5 units from 0. Okay? And of course, the coordinate of this point is -5, the coordinate of this point is +5. Right there are your two solutions. And you want to think in terms of that geometric interpretation whenever you can. Okay, so let's do this now. How would you solve the equation absolute value of x minus 3 equals 5? Well, I'm going to tell you. Okay. This is saying that the absolute value of some number is 5, right? So that number, which is x minus 3, could be -5 or could be 5, right? Okay. So if the absolute value of something equals 5, whatever's inside there has to equal either -5 or 5. So this equation is very important. And I advise you click through videos. Okay? And you should focus on what I'm saying here because nobody ever remembers it the next time I ask. Even though your book gives you a rule and everything, people just leave the absolute value signs off and solve one equation, get one solution, and there are two. Okay? So nobody thinks this through. Please be the exception. Again, this is very important. Just like with quadratic functions, you get two solutions. Well, with absolute value equations of this nature, you get two solutions. What I just said here tells me that x minus 3, if I solve x minus 3 equals -5, I get a number for x that when I plug in here will give me an absolute value of 5, right? And of course, I can solve x minus 3 equals 5 because what we just said, this wasn't hard to understand. If you didn't totally understand it, you really want to look at it again. And you also want to see what open math tells you about it. Probably ask you to memorize, but whatever. Okay? But you want to understand this at the level of, it's not a formula, it's common sense. We understand that there are two numbers whose absolute value is 5. And x minus 3 could equal either one of them. So here's x minus 3 equal one of those numbers, which is -5. And here x minus 3 is equal to the other. We solve, and we get x -5 plus 3, rather than 3 to both sides, which is -2. We can check that. If x is -2, what do we get here? -2 minus 3 is -5, right? Absolute value of -5 is 5. So we just found a solution. Okay. Here. X equals 5 plus 3 equals 8. Okay. Well, I plug in 8. 8 minus 3 is 5. The absolute value is 8. I'll call that 5, right? This is very simple. If you think. Okay. Most people don't think. Most people just remove the absolute value sign, solve this when they think they've done it. Please don't be that way. Okay. Please be sure that you focus on what I'm telling you and what open math will tell you, probably in different words. Okay? And try to understand this at the most fundamental level, which is simply that there are two numbers that make an absolute value equal to any positive number, right? Okay? Yep. Illustrated by this. Absolute value of x is 5, x is -5, and x plus 5. So the absolute value of x minus 3 equals 5, etc. So write down this equation and see if you can solve it. That's absolute value of a, x plus b equals d, with the a, b, and d are no numbers. These are positive number, right? So that means whatever's in parentheses either has to equal d or negative d, right? So that you should immediately just split this equation into whatever your a and b are. This splits into two equations. The logic is whatever's in here has to equal either d or negative d. Okay? If it equals d, then the absolute value is d. If this equals negative d, then its absolute value is negative d. And this gives you two equations that you solve for x. If you haven't written these two equations out, please do and quickly solve for x and then plug back in to see that they work. I didn't see too much. Okay, once you split this into two equations, I saw some little errors in solving the equations, so you want to be sure that you're doing every step correctly. But I think everybody's okay with solving these linear equations. And I don't want to get hung up in solving it. So I'm not actually going to put numbers in and solve this. What I want you to see is that this equation splits into two equations, and I want you to understand why. Otherwise, you're going to forget to do it. At least I expect you will, because 90% of pre-calculus students get to the test and they don't do it. Right there's 10 points coming in. Okay. That's a letter grade. You can't make that mistake. So be sure you understand this. You understand why it's so, which I've taken a lot of time to try to explain. Then you're not likely to make a mistake. Not the third time I've said that, but it's very important. Okay. Please be the first class I've ever seen that actually listens to me. Okay. And it's a stretch. It's a stretch. Okay. And absolute value inequalities. Okay, so we want to talk about absolute value inequalities. Let's do that. So this is in some ways a little more challenging. Okay, so let's just take this. What's the absolute value of x minus 5 is less than 3. Okay. Well, absolute value of any number is less than 3. As long as that number is between -3 and 3. Picture. Any number between -3 and 3 is within 3 units of 0, right? If you understand the picture I made before, right there is the picture you need. So that number has to be between -3 and 3. Now, of course, that number is your 2x minus 5, right? So 2x minus 5 has to be less than 3, right? But it's also got to be greater than -3. So you've got two inequalities to solve here. Well, it's easy to solve this. You add 5 to both sides, and you get 2x less than 8. So the x is less than 4. And 2x is greater than 2, so x is greater than 1. They have to know how to solve inequalities. It's really easy to solve, just like equations, except that if you have to multiply or divide by a negative, you've got to reverse the inequality. And that's something I assume you know, and I'm not going to go over it a lot. You're going to see it in the examples. Okay? So you got to be careful about that. So your solution is all the values that are less than 4, which would be all the values from here all the way to negative infinity, but also and has to be greater than 1. Okay. So here's your solution set. Or actually, I don't want to use arrows. I could use open circles. So if you're used to the idea that an absolute value equation splits into 2 equations, then it's not much of a stretch to understand this, but there's a complication. Okay. So how about the absolute value equality? Same expression, but greater than or equal to 3. Well, first place, you can see that right here's all the values of x that make this thing less than 3. So I guess all other values of x better make it greater than or equal to 3, right? Because it's either one or the other. This thing's either less than 3 or it's greater than or equal to 3. So you kind of store that away. But what you have to do here is okay. As long as that number is greater than or equal to 3, or it's less than negative, less than or equal to negative 3. Now, why do I use and here and or here? Well, because a number can be less than 3 and greater than negative 3, right? There are numbers that are less than 3 that are also greater than negative 3. There's got to be both. Won't go into too much explanation of that at this point, maybe next time, after you've had a chance to work through it and think about it. Okay, here, a number can't be greater than or equal to 3 and less than or equal to negative 3. It's greater than or equal to 3, it isn't less than negative 3, is it? If it's less or equal to negative 3, well, it's not greater than or equal to 3. So, two x minus 5 has to either be greater than or equal to 3 or less than or equal to negative. Number is less than negative 3, then it's more than 3 units from the origin, right? Okay. And if it's greater than 3, it's more than 3 units from the origin. Well, having translated this and being careful about the and and the or, it's real easy to solve. We get x greater than or equal to 4 here, just add a 5 to both sides to 5 by 2. And here we get x less than or equal to 1. Here's our x, and here's 0. And here's 1. And here's 4. X greater than or equal to 4. includes 4, so I put a closed dot here, and all numbers to the right. And x less root of 1 includes 1, and all numbers to the left. Can we see how these two fit together? I mean, whatever is in the absolute value expression either gives you an absolute value less than 3 or an absolute value greater than or equal to 3, right? And that means your solution is either here or here. Everything in this solution is not in this solution, right? And nothing in this solution is in this solution. But if you put the two of them together, you get all possible numbers. Okay. That's when you do the absolute value inequalities with a greater than or less than. I'm gonna have to teach this computer a lesson. Okay, if I use standard values of x, values that we use for all the basic functions, and you've done this. If you did one of the very early assignments, the absolute value function was one of them. So I'm not going to say a whole lot about this. You got to review, but it's pretty clear that if x is 2, the absolute value of x is 2. X is negative 2, the absolute value of x is 2. So we got these points, right? If x is 1 or negative 1, the absolute value is 1. So we get here's 1, here's 1, and here's 1. Then 1/2, yeah, we'll leave that off for a moment. And if x is 0, the absolute value is 0. So you get this graph that you saw early in the semester. We haven't talked a lot about, but there it is. Okay. Now, where's the absolute value of x minus 3? Well, we've replaced x by x minus 3, which means we take all these points and move them 3 units to the right. And the same with these points, and we get points that lie there. So 3 units to the right of this would be about here. 3 units to the right of this would kind of overlap this. I'm not going to draw it. Right there. We have this. Okay. Now, the equation absolute value of x minus 3 equals 2. So that means y equals 2. And I'm not sure I want to do that. I want to change this number. The absolute value of x minus 3 equals 3/2. Okay, well, this is 1, this is 2, here's 3/2, and here's the line for y equals 3/2. And right here is a point on the graph, and here's a point on the graph. X values for y equals 3/2. This is between 1 and 2. So I'm going to say, well, that is about 3/2. And this is between, well, let's see, over here is 4, and here's 5. So this looks like about 4.5. So from the graph, it looks like 3,009 house. Well, we can solve this. You can follow the steps to solve this thing. You get x equals 9/2. And here you get we have, here's a picture of your solution where the y equals 3/2 line intersects the absolute value function. Okay. Also, what about absolute value of x minus 3 less than 3/2? And well, less than 3/2 below this line, isn't it? Okay. So right here's the interval from here to here. We solve the inequality. Absolute value of x minus 3 less than 3/2. X minus 3 is supposed to be greater than 3/2, then you got to be above this line. So all the values of x to the right of 9/2 solve the equation, and all the values of x to the left of 9/2 solve the equation. If you understand all that, you got a pretty good understanding of absolute value functions. Okay. If all you can do is solve the inequalities and equalities, still pretty good. Okay. But if you see it in the graph, of course, you're going to be asked to transform the absolute value function, like I did here. Okay. And reinforce what you understand about transformations. And if you can relate all that together, then you have a really good understanding. Okay. So try to get your basic understanding, but shoot for a really good understanding. Okay. It'll benefit you in the long run. And that's what we're trying to do.